have used ChatGPT 100 times, but have you ever wondered what actually is happening behind that one message you type? How it understands your intent, retrieves context, and produces intelligent response in seconds? And that's the power of building an AI agent, a system that does not just reply, but thinks, remembers, and acts. In this course, we will be learning how to build that kind of intelligence step by step. You'll understand exactly how modern AI assistants work behind the scenes, and more importantly, how to create your own. We'll start with the fundamentals of what an AI agent really is, then move on to setting up your environment, building your first agent, adding memory, connecting real-world APIs, routing tasks, running parallel operations, and chaining prompts for complex reasoning. And by the end of this course, you won't just have a theoretical knowledge. You will build a complete, fully functional AI interview coach powered by Gemini, capable of asking questions, analyzing answers, storing strengths and weaknesses, which will be generating professional reports. This course is practical, hands-on, and designed so that everyone with basic Python skills can follow along and create real AI systems. Here's a quick quiz for you to answer before we start this course. What do you think an AI agent is? Is it a chatbot that talks, a program that can think, act, and use tools, a robot used in movies? Let us know your answers in the comment section below. Now, before we start coding, let's understand the most important question. What exactly is AI agent? An AI agent is a system that can understand input, think or reason, take actions, learn from interactions, and optionally remember things. Think of AI agent like a smart assistant that does not just chat. It does tasks. It can call an API, fetch weather, understand context, plan steps, analyze response, and make decisions. Examples of some of the AI agents you're already using is Siri or Google Assistants, ChatGPT with tools, recommendation systems, customer support bots, and also automated interview trainers. In this course, we are going to build agents like these, but customized for your cases. AI agents are the next big wave in automation and productivity. They matter because they can automate repetitive tasks, make intelligent decisions, work across applications, perform multi-step reasoning, and also personalize your responses. They also can handle real-world workflows. Companies now rely on agents for customer service, interview screening, scheduling, tasks, finance automation, and more. Learning these skills gives you a huge edge in 2025 and beyond. Now don't worry, you don't need to be an AI expert. All you need is a basic Python knowledge, basic understanding of installing libraries, an interest in building AI tools, a free Google Gemini API key, which I'll tell you how to get it. And that's all. If you know how to write simple Python functions, you are ready. Now, before starting, make sure that you have Python installed, which is at least 3.7 plus version. So for that, just visit python.org.downloads and you can download the latest version from here. Now, how to check Python is installed? It's Windows R, CMD, and you can just give Python and a version should be printed. Here mine is 3.1, 3.7. Anything which is 3.7 plus version works good for this. So after this, you have to install few of the Python libraries. So first, let's just install OpenAI itself. So it is pip install OpenAI. So it installs all the packages. Next, we have to install some general purpose libraries which make HTTP request pip install request. So let's move ahead with that. Pip install request. And next we are using an fast API. So for that we need to install Flask. So again pip install Flask and also fast API. So pip install fast API. Next we also need .env, which is for storing your key in which we have to read it in the program side. So for that we have to install python.env. So for that pip install .python.env. Okay, there was an error. So it's env. So since I've already installed this, it's already showing requirements already satisfied. Git is also necessary for version control and cloning repositories. Now you can download Git from gitscm.com. So this is the interface, and here you can see installed for Windows. You can just go ahead and download it. Make sure which Windows is portable with yours. Just click on it and download. Now, how to check if the Git is installed? The same way as we checked for Python. We just need Git version. So here you can see it is 2.52.0 Windows 0.1. So this means that your Git is also ready to go. Now to use OpenAI models, you also need an API key. So for that, you can use OpenAI or even Google. Now to get the API key, you can just visit platform.openai.com, create your account here, enter your email ID, give a good password, and you'll get this interface. Now here on the left side, you can see API keys. So you can just click on that, and there is a plus button which you can click on and you can create your key. So you can give a name and a project as required and create a secret key. So let's create a key for now. Let's say I'm using a test and the project saying default, and create a secret key. Here you get an option of copy. So just copy it. Now whatever project I will be doing, I'll be storing into a folder. So let's create a folder. So you can go to the core and create a new folder. Let's say default or test. And the first thing that you have to create is a .env folder to store your API key. So .env, press enter and yes, open it. Now .env folders are used to store specifically your API keys. So you can give API in caps is equal to and paste the key that you have copied from OpenAI. So let's just save this. And then next again I have to create a .py folder. So let's just say it is app.py, which is a Python. So and yes, and let's give a simple program. So firstly, the first step is you have to import function load. So from .env import load.env. So this will be common for all kinds of programs since you have to load it from a .env function. Next, let's import OpenAI since that is the one which you are going for. For Google also, we'll use a different programming style. We'll come back to that. This imports all the OpenAI Python SDK, so we can make API calls. And then we have import OS, which imports OS modules to access environment variables from the system. And now to load environmental variables from .env file, we have another code. Let's say we have load.env, and this reads the .env file and loads all the variables. Next, we have to get an OpenAI key from the environment. So let's just say OpenAI API key, which is equal to os get env. Now here you have to input the folder name that you have given. Not exactly the folder name, but we have given API key is equal to so and so key. So input that. This fetches the value of the open API key from the environment. Next, we have to use this key on our OpenAI API call. So for that, it is OpenAI.API key is equal to OpenAI API key. Now this sets the Open API key so that the SDK can automate requests. Now let's just see an example of API call to OpenAI. So for that, we need response is equal to OpenAI dot completion dot create, and let's just give engine is equal to text 3, and then let's give prompt also. Prompt is equal to say this is a test. Let's give the maximum number of tokens also. Now here response is equal to OpenAI.completion.create. This calls the Open API to generate a text compilation. Now which text compilation? It is specified in the engine, which is text DaVinci 003. You can use anything as you wish. And then I'm giving a prompt, which is say this is a test. And the tokens also have been mentioned, which is 5. So this limits the output to maximum 5 tokens or words. Let's just at last print the responses. So it will be print response.choice Now this prints the resulting text response from the AI, removing extra spaces. Now after getting your API code or a key, optionally you can download any cloud or local developmental tools. For instance, we have Docker. If you are deploying your AI agent in a containerized environment, you will need Docker installed. Apart from Docker, you can use even Heroku, AWS, Google Cloud. Now let's move on to setting up the project directory. If you have already not created a project directory, the structure, the files are discussed. Firstly, we'll need a .env folder which contains the open API key. And then we have to have a Python folder which runs the main Python script. So here it is app.py. And next, optionally, we can create a .text folder which stores all the requirements. So you can just run the requirements and you will have all the Python libraries or other libraries which are required. And next, again, optionally, you will be needing a readme.md, which is a project documentation. So on the go, you can store what are the changes done in the program, or any information about the project can be stored in that too. Since the API key from OpenAI requires money, here's another way out, which Google API key, which is free. So let's see how to get the key. So first you have to visit ai.google dev Gemini API and create your folder with just an email and a password. So here you can see the option of get API key. So you can just click on it, and here you can see my previous keys. If you want to create a new one, again, here's an option of create API key. So you can just click on that, name your project and chatbot, create a key, and you will be creating a key. Now how do you copy that? Just copy API key option is there. Now make sure for your security purposes, do not share your API key with others since they can misuse it. Now the next step is to copy this API key. Go back to the .env folder and you can see open API key, just change that. Now from here you can just copy your API key, go back to the folder where .env was created, and you can just give Gemini API key is equal to and paste the key over there. And you can just paste the key over there and save it. So this key will be used throughout your coding program, since we can call small functions to access this particular key. Now after getting the key, the next important part is to install Google Generative AI. So for that, just go open command prompt and open your folder over there. So it's cd, the location, and enter. So it will navigate to the folder, and then here the code to install Google Generative AI will be pip install Google Generate AI, and I'm giving a particular version with this. You can go with the latest version and just run the code, and as you can see, it will get installed. Now to check really if this is installed, just run pip show Google Generative AI. And here you can see the version, name, summary, homepage, author, etc. All the details should be displayed. Now let's just start with coding a simple program. So where will the main program go? It's app.py. So let's start with importing Google Generative AI. So for that we have import Google.generative AI as Gen AI. Next, we have to import .env. So we have from .env import load.env. And next, obviously, we have to import the OS. So import OS. Next, we have to load the key. So for that, we have load.env. Now we have to get the value of the API. So for that, we have API is equal to OS get env Gemini. What is the name that we have given? API key. So this retrieves the value of Gemini API key from the environment variables. And let's say suppose there is no key available, we'll have a backup. Repeat. So let's say if we don't find any key, we should have a backup of printing an error message. So for that, if not API key, if there is no value in the API key, let's say print an error message. So what should be the error message? Let's print error, no API key found. And let's let exist from this group, exit loop. So this loop prints an error message if there is no API key and exits the loop. So after this loop, let's configure Gemini API client service. So for that we have genai.configure API key, which will be equal to API. Now the next step is to create a generative model. So for that we can use model is equal to genai dot generative model, and let's give a name of the model. So we'll use models from Gemini, the 2.5 Flash, which is the latest one. So this is specifying which model to call. Next we have to define a function which is chat with agent, and the values which is going in is the prompt that we given. So we'll use a try loop for this. So response is equal to model dot generate content and the prompt. Now this generates a content from the given prompt itself, and then let's just print the given information, AI response, and let's see what the output will be, which is response dot text. Now for the except loop, we have except exception as E. Here, if there is no such kind of information, let's just print error. And at last, let's call the main function, which is if name is equal to main slash, then we say we have to call the function. What was the function name? Chat with agent. And let's give a prompt. Let's say, tell me a funny joke, AI joke in one sentence. So this will be the prompt that we are giving in, and the AI will go through the sentence and give the information as provided. This is the main block where we are calling the function. So let's just run this code. How do you run this code? Again, Python, the folder name, py. So there is an invalid syntax of the main block. So let's just rectify that. So I had missed out on the double dash. So I have fixed it. So let's go back and say it's showing an error. So we'll check that out. So let's just run the program again. Now what was a prompt that was given? It was to ask or tell a funny joke about AI. So the reply was, why did the AI break up with the calculator? It felt like it was just adding to its problems. That's the prompt given by the generative AI Google model. So make sure you check with the code. If there is any error coming, just copy and paste the error in ChatGPT or Gemini. So it'll give you what are the corrections to do and why the error occurred. So this way you will have an understanding of what the problem actually is and how to sort it out. Now that our first agent is working, let's go one step deeper. An AI agent becomes powerful when it can fetch real-world data like weather, time, calendar, events, emails, or even stock prices. Here you will learn how to make an external API call from our agent. Now the first step is to install requests, which we have already done. So let's just install it again. Pip install requests. The request library allows Python programs to communicate with any external API, whether it's Google Calendar, weather, or even custom backend. Now to run this program, let's create another folder of Python in the same folder itself, and let's say API tools, and yes, you have to change this and open it. Now let's start with the coding part. Let's say we have to develop a program which prints the date and time. So for that, the first part would be to import requests, and next let's define a function get current time. So for getting the time, we are defining this. Let's not pass any parameters now. And then we'll give a URL where the actual time is been present. So here's the link where the actual time will be running, which is a API. This API endpoint that returns the current time for the Asia or Calcutta time zone. Next, we have to send a HTTP request. So for that, we have response is equal to requests to get URL. So from the URL, we are getting the time, which is the response basically. And then another response that we want is the response dot raise for status. Now this raises an error if an API calling fails. Suppose if they're not able to get the time, it shows an error message. Next we have data, which is equal to response in file. Now this converts the JSON file into a Python program or even a dictionary, and then we are return data date time. So this is the coding for retrieving the date and time. Now here's an important thing. Never run this file directly. This function sends an HTTP GET request to public time API, receives a JSON response, and extract the current time. This is how your agent will interact with any real-world data sources. So next, let's just create another file to integrate the API to call the agent. So again, let's just create a folder which says agent API call. Again, it should be a Python, so .py. And yes, now after creating the agent API call, here's a small program that I've integrated with it. The first sentence, again, it's importing Google Gemini AI, then I've imported .env, then I've imported OS. This and all is a normal thing that you have to do in every Python folders. And then we have from API tools import get current time. This imports our custom function that fetches the real-time data. Next we have load.env, which again loads all variables stored inside the .env file into the environment. And then we have generative AI configuration, which configures Gemini API using the key stored in the environment. Next we have model. Again, I'm mentioning the same model, which is Gemini 2.5 Flash. And then we are defining an agent with API with the prompt in it. So this is a function that processes user input. For example, if the user asks call API tool, next we have if time in prompt.lower. So here what happens, this checks if the word time appears in the user's question, which is a very case sensitive process. And then we have given real time is equal to get current time, which is calls our external API function to get real time data. And the prompt also, we are breaking that down, which is equal to prompt plus is equal to real time data, current time is equal to real time, etc. So this adds the fetch time into the prompt, sends extra context to the AI model. And then we have response is equal to model.generate content within the prompt. So this calls Gemini to generate a response based on the updated prompt. And then we have return response.text, which returns the text response back to the user. And lastly, we have the main module, which ensures this code runs only if the prompt is provided. I have given a prerequisite code or a prompt, which is what is the current time right now. So this will be a prompt. You can change the prompt to whatever you want. Now in this entire date and time, here's what we did. If the user message contains the word time, we call an external API, which is get current time, and we insert the real world data into the AI model prompt. Then we have the agent now, which responds using both reasoning and external information. So let's just, if you run this part of the program, which is API call, which is agent API call, you will be able to see the current date and time as per your prompt. Up until now, our agent has been completely stateless. It responds to each prompt independently and forgets everything after it replies. Real intelligent agents need memory. Memory allows an agent to remember user preferences, recall the past tasks, track multiple step activities, understand long-term context. Next, we'll build a long-term memory for our agent. Short-term memory exists only during a single run and resets when the program stops, whereas long-term memory persists permanently, meaning the agent can lead about you and remember it across multiple sessions. We will implement long-term persistent memory that saves information even after you choose the app. Our memory system will use a very simple and reliable structure. The first one is a JSON file. So as you can see, we have agent memory JSON, which stores all the past conversation. Next, we have a memory manager that reads and writes to this file. The agent retrieves the last 3 to 5 interaction for context. Memory grows over time just like a human brain. Now, firstly, we need to create 3 Python files, which is memory manager, which stores and retrieves memory. Then we have agent with memory, where AI agent logic, which uses memory. And next we have test memory agent.py. This runs the entire conversation. Now we'll see what's there in memory manager.py. Now you can consider this as a brain storage. The first purpose is this file stores and retrieves long-term memory. It has code to create a memory file, which is agentmemory.json, and it also has a function to save the interactions. It also has the functions to load the past memory. Now this file exists because the memory should be independent from the agent logic. This file is like the database of your agent. So firstly, we have import JSON here. So imports all the JSON module to read and write. Next, again, basic is import OS, imports the OS module to interact with files. And then we have the memory file. This is the name of the JSON file where the agent memory will be stored in it. And next, to create memory file, if not exists, we have another code. So if not os.path exist memory file with open memory file, w as f JSON dump history. So here what happens is it checks if the memory file already exists. If not, creates a file in write mode and then writes an empty JSON structure. So here in json.dump, it initializes a list where memory records will be stored. So if you don't have any JSON files existing in the folder where your program is, it creates an empty JSON folder. So in future, you can store all the interactions in it. Next, we have a function which is save to memory, which takes the input as user text and agent response. And we have save users plus agent message into a long-term memory. Now, this memory is getting saved into the JSON program. Now, this function is getting stored into the JSON file, which we have created or it creates by default. Next, we have with open memory file, r as f. This opens memory file in read mode. And then we have data is equal to json.load. This loads the JSON content into the Python dictionary. Next, we have data history.append, which adds a new memory entry, which is a dictionary or a history list. Similarly, we have users with user text, which stores the user's input, and agent, which stores the agent response. Now, if you come down here again, we have with open memory file again, w as f JSON dump data f indent 4. So this opens the memory file again, writes the updated memory back file and print it. Next, here again, we have another function which is get recent memory. This retrieves the last memory. Again, this with open memory file, this opens a memory file, read existing data, loads the JSON file into a Python dictionary, and then returns the last n conversations which has happened recently. Now let's just save this and move on to the second file, which is agent with memory. Again, here we have all the basic libraries, which is Google Generative AI as GenAI, .env OS, and then we have memory manager also. We have imported save to memory and get recent memory, which we have mentioned in the previous one. Now, this file is the thinking unit. This file defines how agent uses memory to answer the users. This fetches the code, the last n memories from the memory manager.py, and also the code that combines memory plus user's question. It also has the code that sends the enhanced prompt to Gemini. Then it also stores new memory again through memory manager.py. The information that it processes will be past memory, current user questions, the AI responses, and even the updated memory. And talking about why this file, it's because the agent needs a clear place that handles reasoning, context building, prompt creation. This file is like the AI brain. So as I mentioned, all the basic libraries are imported. So here we have load.env and API key. and also gen AI configure API key. This is also very normal as you have already executed this. And then model also 2.5 flash, it's the same. Now coming here, we have a function which is AI agent with memory with user input, and the past memory is equal to get recent memory. So here it defines a function that takes the user's new message, load the last 3 interactions, which is past memory, and then it retrieves the last stored conversation entries from the memory. And then we have memory text is equal to with double quotes. This creates an empty string to store formatted memory text. And then we have from item in past memory, memory text is equal to plus f user, item user, agent, item agent. So this loops through each memory entry, adds both user message and agent reply into the memory text. Now again continuing, we have final prompt is equal to f. You are an AI agent with memory. Here is your past memory. So this insert a conversation history to the prompt. This will be the starting of your conversation. And then we are moving on to now answer a new user message. So this inserts a new user question into the prompt. Now here we have response model.generate content, which is combined prompt to Gemini to generate a response. And then we have answer is equal to response.text. This extracts the text output from the model. And then to save both user query and AI answer, we have save to memory user input comma answer, which is stores the latest user messages and AI response. This updates the JSON memory file so the agent remembers it later. And then we have to return the answer. Now talking about the third file, which is text memory agent. So let's open that also. So this I would call it a chat interface. This is a file you actually run. So what and all it contains? It contains a loop asking the user for the input. It passes the input through the agent with memory dot, which will be called in the program, and then it displays the agent response. It also keeps the chat going. And what information does this handle? It handles user messages, AI responses. Now here no memory is stored. It delegates storage to other files, such as the JSON file which will be created. Now this file exists because students needs clean, simple entry point to test the agent. From agent with memory import AI agent with memory. Now let's start with the programming part. So here you can see from agent with memory import AI agent memory. This imports the main functions that handles memory, builds the prompt and generates a response and saves the conversation. Next, we have print AI agent with memory text exit to quit. Here it displays a welcome message and instruct the user how to quit the program. Then we are entering into a while loop. This starts an infinite loop to keep the chat running, and then we have user message, which takes the input from the user every time they are typing something. Now there is a if loop. If there is a message called exit, it breaks the loop directly. Or else it will be reply is equal to AI agent with memory user message. So this sentence basically sends a user message to an AI agent with memory, and the agent responds and updates the memory. And lastly, we have to print. So we have print the AI response on the screen. Now let's see the back. How did we do this entire 3 files? So we have user, then we did test memory agent.py, which will send a message to agent with memory.py, combines the memory plus the question and requests the pass memory, which is the memory manager.py, provides the memory, returns the pass memory to agent with memory.py, which will be generating reply plus saves new memory. Again, this memory will be sent back to the user, which is called in the test memory agent.py, where the answer will be displayed. So let's just run this folder, which is test memory agent, and see what the output looks like. So here, firstly, I'm navigating to the folder, and then we have Python. What was the name? Agent, test memory agent. So we have test memory agent. So let's just run this. So you can see AI agent with memory, type exit to quit. So let's just say, hi, my name is Susan. So here the agent replies saying, okay, Susan, I'll remember that your name is Susan. Let's say my age is 32. So it is remembering the age as well. And let's say I work in the domain, let's say data science. Now it is remembering 3 information. Let's ask if the AI actually remembers. So let's just ask what my name, age, and domain that I work in. So as you can see, your name is Susan, you are 32 years old, you work in a domain of data science. So it actually remembers our past 3 conversations. You can increase the number of conversation as per your wish. Up until now, our agent can remember information, call external APIs, and generate the responses. Now we are adding 3 powerful capabilities. The first one being prompt chaining, second one being routing, and third we have parallel task execution. These techniques are what real-world AI assistants use to break down tasks, pick the right tools, and work more efficiently. These techniques are what real-world AI assistants use to break down tasks, pick the right tools, and work more efficiently. In prompt chaining, the agent doesn't try to do everything in one go. Instead, it performs multiple steps and uses of the output of one step as input the next one. Now let's take an example now. If you input explain Python decorators and give an example, without prompt chaining, agent tries to answer everything at once, often which is messy. With prompt chaining, agent breaks into clear steps, which is understanding the concept, explaining it, generate an example code, and even summarizing it. So let's write a code for this. So again, starting with the basic import variables, which is Google Generative AI as Gen AI. We have .env to read the API key and also import OS. And again, we are loading the .env and the API key specifying the model. This is basic, again, repetitive in all other programs as well. Now here we have a function which is def chain prompt, which defines the function named change that performs prompt chaining. And then for step 1, we have step 1 is equal to model.generate context, f break this task into clear steps. So here it calls the Gemini to perform the step 1 of chaining. And here f break this task into clear steps. This is AI returns a step-by-step breakdown of the user's task. So we are asking the Gemini directly, what parts can this question be divided into? So it will give us an answer. And next we have print ln step breakdown 1. So this prints the breakdown so that user can see how Gemini structures the task. And then moving on, we have step 2, which is step 2 is equal to model.generate content. Now here this will call Gemini again for step 2 and AI produces a detailed explanation using the step breakdown. And we are also printing the detailed explanation of the step 2. Again, coming to step 3, we are asking the agent for final summary. So here again we are calling the Gemini. AI returns beginner friendly summary and also we are printing that final summary. This is return step 3. The final results will be returned in this step. Now again, main part of the program which calls and runs the entire program, which checks if the file being executed directly or imported. And then we have chain, explain Python decorators with an example, which runs the chaining function on an example prompt. So here we have already given the prompt of explain Python decorators with an example. So you can change this as per your wish and check if it follows all the steps. So let's just run this folder and see what will be the results. So again, how do you run the program? Same way, Python, the folder name is prompt chain agent.py. So we had asked a question of what is a decorators. So we need 3-step explanation with the summary. So let's see if that is given here or not. So here you can see step breakdown. Let's break down the explanation of Python decorators into clear, easy to follow steps. We have step 1, introduction of what decorators are. Then we have prerequisites, which is understanding the building blocks, which is the second step. And we have the third one, which is building a simple decorator. And then followed by 4th step, which is applying a synthetic sugar. 5, 6, 7, it is divided into multiple steps, which is handling argument and return values. And then 6, 1 should be real world examples, real world use cases. And as I remember, the last part should be summary. So let's just check with that. So here you go. There is a summary provided on entire Python decorators. So much of information we have acquired due to chaining process. Now coming to the next powerful capabilities, which is routing. Routing means that the agent decide which tool or method to be used based on the user query. This is how ChatGPT decides whether to use the browser, use Python, use memory, or even use image features. And it also specializes in using specific tools. We build a simple router using Python keyword detections. So let's go through the code. The first one, again, basic things which are imported, which is Google Generative AI .env OS. The extra thing which is imported is API tools, which we are getting get current time. So as you remember, we had done a program which gets the date and time. We are using that here. And then continuing with load.env gen AI configure the model that Gemini should use. Coming down here, we have a function which is router agent, which passes through query. So here, this function that routers the query to a current logic. And then we have if time in query dot lower, which is if the user's message contains the word time, this will call a function to fetch real-time data and returns it. Then we have another if statement, if explain in the query, which is if the message contains the explain, then it asks Gemini to generate a simple explanation of it. And then it returns the explanation back. Then we have default fallback, which is response is equal to model.generate content query.text. If no condition is matched, then just ask Gemini normally. Then we have return the responses, and again we are calling the function, and the input that we are giving is what is the time now, which is the question, and then we have also given another input which is explain recursion. So let's just test both the outputs. So here again, Python, what is the folder name? Router agent py. Let's just run it. The two questions are what is the time now and what is recursion. So let's see if it answers. So here you go, the current time is so and so, it is already displayed. And then you have recursion. So imagine you have a task, instead of doing the whole thing yourself, you figure out how a tiny part, etc. This is all regarding recursion. In short, recursion is a function of instructions that solves a problem by calling itself with a simpler version, etc., etc. So we've got an answer for both the question. So according to the keywords that you are using in your prompts, it generates the kind of answers which is suitable as per your prompt. Now, the next thing we are going to see is a parallel task execution. Gemini supports running multiple prompts at once, which is parallelization speeds up the agent. If the agent needs to do 4 tasks, do them at the same time instead of one by one. Now, let's put this on code. Firstly, starting with the normal, importing google.generative AI as gen AI from .env, import the .env OS. The only thing which is imported separately, which is import concurrent futures, which allows running the prompts parallelly. And then normally we have load.env, and this is regarding the Gemini API key, gen AI.configure API key.os, etc. We have also mentioned the model name. Now here we have a function which defines the sends or returns only text output, and then we have generates content and returns only text output. It's basically one text at a time, but with 4 routers. So yeah, we are entering one prompt which asks the Gemini to generate the answer for it, and then we have the prompts such as summarize Python in 200 words. This is for execution part. Explain AI agents in simple terms, give a motivational quote, write one in-line definition of API. So these are a list of tasks that will be executed parallelly. Again, if you come down here, we have with concurrent.futures thread pool executor as executor. Here it creates a thread pool to run multiple operations simultaneously. And then we have results is equal to list executor.map as Gemini prompts. So here maps each prompt to ask Gemini function and execute them. In parallel, all the results are collected into a list format. And here for the result, we have for RN results, loops through each AI generated response, and then we are printing the same response in a loop. So let's again run this and see if all the 4 prompts will be able to get it at one go. Now let's just run this program. Now here you go, all the 4 prompts which is answered within a few seconds. Instead of writing one prompt and waiting for the answer, writing another prompt, waiting for the answer, you can get all the 4 prompts answer at one go. With these additions, your agent can break down the task, choose the correct tool, and even execute multiple tasks at the same time. Also, it will respond professionally and intelligently. These advanced capabilities bring your agent much closer to real production-level AI assistants. Now, with all the knowledge that you have gained, let's build an end-to-end project. Let's say that you have to build a complete AI interview coach using Gemini and Python. This assistant will act like a real interviewer, ask questions, analyze your response, store your weaknesses, and generate a professionalized feedback. Let's name the project as AI Interview Preparation Coach. Mainly, let's have a project structure for this. So, again, as we did in the start, create a folder with all the necessity files required. Starting with, I already have here .env which stores the Gemini API key. We have roles.py which has list of different roles and store the keyword. And then we have interview agent.py which is a main agentic logic. And then we have memory manager.py. Again, it's a long-term strength or even a weakness memory. Followed by we have tools.py which is tools like time, scoring, keyboard, check, etc. Then we have router.py which routes tasks, analyzes questions and feedbacks. And finally we have mockinterview.py which runs a full interview session. And then by default interview memory.json which stores the interview history. So let's get started with the final project. First, let's start with creating folders and files. So you can just create such files. And then as usual, .env file, load your Gemini API key. The second file should be roles.py. Here in this Python code, you can enter the domain and couple of domains for initially providing the chatbot with options of which interview you want to practice for. So here you can see interview roles. I've given it software engineer, Python developer, data analyst, machine learning, cybersecurity, cloud engineer, project manager, digital marketer, and HR manager. And I've also included some of the keywords related to these roles, which is OOP, DSA, algorithms, so that the AI would be able to fetch questions based on these topics or even keywords. Now coming here, you see a function to let the user pick a role, and then we have a greeting message saying welcome AI interactive coach, and it will also say print the role to begin your mock interview with. Now we have all the roles in the list here, interview roles. So here .key. So we are going to list all the interview roles that we have created. And then for looping, we have for I, R in enumerate roles. Start is equal to 1. This here loops over all roles with numbering starting from 1 to 9 since I've given 9 different positions or interviews. And then we have printf, so it prints each roll number and a title case. So this will print 9 HR manager, 8 digital marketers, such like that. And then we have choice int input, enter a number of roles. So if you enter 1 to 9, any number, it fetches question based on the specific domain that you have been choosing. And then we have role is equal to roles choice -1. This maps the number to a correct role in the list. And then we have print, and then we have print use select. So displays the selected role to the user. So whichever role that you have selected, it will print back again. And then we have return role, interview roles, which is returns both the role name and its metadata. So here is about the roles, which is the basic starting. Now, since the initial part, moving on to the next one will be tools.py. So here you have the F keyword, match score, answer comma keywords. This is a function to count how many expected keywords appear in the user's answer. And then we have scores the user's answers based on the keyword presence. More keywords is equal to higher score. And then we have answer is equal to answer dot lower, which converts the user's answers to lowercase for case sensitive matching. And then we have match is equal to sum 1 for k in keywords. If k dot lower in answers, then return match. So here it returns the number of matched keywords. So if you give an answer to a particular question, it has a pre-built keyword. So it matches the entire keywords and gives you a score. Next, here we have function to generate score, keyword score, comma difficult, which is equal to medium. Here converts the keyword count into final score out of 10. Now difficult slightly adjusts the scoring curve. And then we have base is equal to keyword score into 2. Each keyword adds 2 points to the base score. And if difficult is equal to hard base minus is equal to 1, and else if difficult is equal to easy, base plus is equal to 1. So if the interview difficult is hard, we reduce the score slightly. If the difficult is easy, give a small bonus. Now to keep the score between 1 and 0, we have return max 1 and minimum 10, comma base. And moving on, we have another function which suggests which important points the users have missed. So for that, we have answer is equal to answer dot lower, which is lowercase the answer for uniform matching. And then we have missing is equal to k for k in keywords. If k dot lower not in answer. So this creates a list of keywords that did not appear in the answer. And then we have missing list is equal to an empty array dot join missing. Return F, you have missed these important concepts, which is the missing list. Try including them next time. So here it gives a feedback saying these are the concepts that you have missed and try to include them in your next answers. The next function will be def classify strength or weakness score. So this classifies performance strategy category based on the score. We have basic rule to classify users' performance. If the score is greater than or equal to 7, we are returning strength or we are returning weakness. So basically we are judging based on the answer if your score is a strong one or a weak one. Next, coming to here, the last function, we have the F short feedback. This gives a short qualitative comment, which is simple quantitative feedback based on the score. So here, if it is greater than or equal to 8, we are providing a feedback excellent answer with strong and clarity. And then if it is between 6 to 8, we are good answer but can be more detailed. And then we have decent attempt but lacking key concepts. And if it is less than 4, we have weak answer, need major improvement. So this is the feedback. Next, we have memory manager.py. So let's open that. Here, long-term strength or even weakness memory is adapted. So starting with, again, basics are important, which is JSON. Since it is a memory.py, you need a JSON format. So we are importing JSONs well and good in the first place itself. And then as usual, we have operating system, which is import OS. And then we are loading in a memory file, which is interview memory.json, which is a file name where all interview memories will be stored. Now to create the memory file, if not exist, this checks if the memory already exists or not. If not, it creates an empty file, which is interviewed memory.json, and the history is empty, strength is empty, and weakness is also empty as per now. So as we have the conversations or as the interview takes place, the memory will be stored in the JSON format. Now coming on to the next function, which is df save interview record role, question user answer feedback. This is save one Q&A record to long-term memory with open memory file r as f, data is equal to json.load f. This entire loop loads the existing memory file contains into the Python dictionary. And then we have data, which is history, role, question, answer, and feedback. These are the things that can be stored in the JSON format. So this adds a new interview entry into the type of the interview conducted, the questions asked by the AI, the user's response, the full feedback, which is score, strength, or even weaknesses. Then coming down, we have with open memory file w as f json.dump data f indent is equal to 4. Here this saves the updated memory back to the disk with formatting. Next we have another function which is save strength, and we have with open memory file r data is equal to json.load f data strength.append strength with open memory file w as f, and we have json.dump data f indent is equal to 4. So again, here it loads the current memory into the dictionary, adds new strength data into the strength list, and also writes updated strength back to the file. Similarly, we have save weaknesses. It's the same code, just it is replaced with the weakness function or weakness information. And lastly, we have function which is get memory summary, which is retrieves memory for personalized reports with open memory file r as f return json.load. This returns an entire memory including history, strength, and weaknesses. Now let's code interview.interviewagent.py. Again, here also basic imported functions, which is google.generativeai.env and operation system. And then we have from memory manager, import save interview record, save strength, save weaknesses. From tools, import so many tools. So here all the memory manager, all the classes that we have defined or even functions, which we have to use it in the entire program, we can call it here. And then we have load.env, which is basically about the API key. These three are again a constant in every program. So here we have function which is generate questions, role prompt is equal to f. So here Gemini generates one interview question, removes extra spaces, and returns. Next we are moving into function 2, which is analyze user's answer to the interview question. Here again we have role specific important function, and then we have data which is difficult, easy, medium, or hard, and we have different scores. So first score, user answer based on the keyword matches, convert keyword. This and all we have already performed, we are just calling it. So again, as you can see, provide a short analysis. Until here it is called, then you are an HR expert. This is a prompt given for the Gemini and senior interviewer. Evaluate this answer for the role of whichever the person has selected. The candidate answer, the final score is also being printed. Strength, weaknesses based on the keywords, and also provide a short analysis, which is 2 to 3 lines, which will be printed after the interview is done. One sentence on how to recruit will be receive this answer. One actionable improvement tip. Make feedback helpful but not harsh. So these are the instructions or the prompt that we are giving to Gemini. Then we have AI feedback is equal to model generate content analysis prompt dot text dot strip. Then we have to store the strengths and weaknesses in long-term memory, which has already been created in a previous program. So here we have store strong answers, store weak answers, etc. So you can go through this code, and we have what are the return values. We have score, improvements, brief feedback, and AI feedback, all via Gemini. So these things will be returned back to us. Next we have router.py. So let's just check what and all goes into router.py. Here we have from interview agent import generative question analysis answer. So this import question generation plus answer analysis. Then we have to import functions to save interview results plus load the summary. So we have a function for that, and we have a class which is interview router. This is a main class that controls the interview flow of it. And then we have a class. Under class we have the first function, which is in itself role and role data. So here the selected interview role, example, if you select software engineer, etc., it will be stored here or asked here or even looped here. We have role as metadata, and keywords will be selected. Counter for how many questions totally. So as you can see here, we have from interview agent import generate question and analyze answer. And then we have from memory manager import, save, interview record, get memory summary. So here this imports question generator plus answer analysis, and also here it import functions to save interview results plus load memory summary. Then we have initialized an entire class, which is the main class, and under which we have first function, which is init. Here the selected interview role, for example, if you select a software engineer or data science or something like that, will be iterated. Next we have role, which is metadata, keywords, etc. Next we have counter for how many questions, total interview questions. Truly only when waiting for stores an active interview questions. So here this is basically the limits that we are setting. Suppose the amount of question, maximum answers, waiting for the answer, current question, etc. So for this we have initialized in init role, and we have passed the parameters of self, role and role data. Next, here we have the next function, which is a def next step, which passes the parameters of self, user input is equal to none. And here we start the interview question, which is ask first question. So here we have given if self.question count is equal to 0, return self.ask new question. So if the waiting for an answer, it analyzes it basically. And then for the second question, again, we have if self.waiting for an answer and user input, return self.process answer user input. It repeats until the maximum number of questions. So we have 3 questions, so I have iterated it thrice. And then lastly, we have return self.final report, so which returns the final summary. Next, we have one more function, which is def ask new question, where we have self.current question is equal to generate question self.role. Here it generates interview questions from Gemini and it increases the question count, and this is the waiting for a user's response. This returns the structured data so front end or displays knows what's happening. So now here you can see we have return type question text self current question. So this tells UI this is the question and this question text itself. Now next we have another functions under the class, which is process answer, which the parameters are self and user answers. So under this we have self.waiting for answer is equal to false. So if we receive the answer, no longer waiting. And for analyzing answers, return scores, missing keywords, AI feedback, etc., we have feedback is equal to analyze answer. We are calling self.role, user answer, and self-role data. Now to save this record in long-term memory, again we have save interview record. Which are the records that should be saved? It is role, current question, user answer, and the feedback. Now coming here, we have return. We are returning type analysis, score feedback, and a brief feedback also, improvements and AI feedback. Now this indicates analysis feedback, numerical score which is 1 to 10, and we have short hint like feedback, missing keyword suggestion, and also detailed critique generated by Gemini. All these will be returned back. Now here's the last function, which is def final report. Memory is equal to get memory summary. Here long all term memory, return structure summary, and then again return type will be final project, total questions, strengths, weaknesses, and a message. Interview completed, review your performance summary below. This will be signaling the end of the interview, how many questions were asked, showing the last 5 strengths and showing the last 5 weaknesses also. So this is how router.py will be there. And the last one we have mockinterview.py. So here starting with from roles import choose role. This is import the role sector, which shows the available roles plus returns the user's choice. And then we have from router import interview router. This imports the interview controller that manages the entire Q&A flow. Coming, we have the first function, which is def run interview, and it brings AI interview coach with some is equal to sign. Now here it asks the user to choose the interviewer role. So we have role, comma, role data is equal to choose role. So whatever role we are choosing, it will be stored here. So next we have to initialize the interview flow manager. So here we have router is equal to interview router, role, comma, role data. And after that we have print starting the interview. So this loops continues asking questions until the interview ends. Now coming on to the while true loop, we have while true step is equal to router dot next step. This is the case 1 where the system is asking a question And in that question, if step type is equal to question, print question router question dot count is to step text, and answer is the input your answer. So here it displays the question, gets the candidate answer, and process the answers through the router. And next we have analysis is equal to router dot next step answer. Here it gets the candidate's answer and process the answer through the router. Now to display scoring plus feedback, we have print feedback, analysis, quick feedback, missing points, AI feedback, and analysis on the AI feedback. Now next we have interview is completed, which is case 2, which is in else if. So here you can see step type, final report, print, final interview report, and then we have print F, total questions answered, step total questions, and print your strength, if strength, and then print, else it is print no strengths recorded yet. So basically here we are printing the strength summary, and when we move down here we are printing the weakness summary. And this is the final closing message, which is print N, step message, print just is equal to symbol and break from the loop. Now again, this is run the interview if executed directly itself. So, and then we run the interview. So this loop will be executed when we call this function. Now let's just run this code and see the output. So again, copy and paste the location. So then copy and paste the location in CMD so that it navigates to the folder, and then here run the Python code, which is Python mock interview .py. So here you can see it is printed the message of AI interview coach, which is welcome to the AI interview coach. Choose a role, begin your mock interviews. So we have software engineer, Python developer, data analyst, machine learning engineer. You can add as per your knowledge. So let me go with 3, which is data analyst. So you have selected data analyst starting the interview. What is my first question? Imagine you are tasked with investigation a sudden unexplained drop in a key business metric. Walk me through the process for identifying the root cause and preparing your findings. So this is a practical question. So you can answer as an interviewer asks you what are the procedures that you might follow. So here I have given an answer of I would start by verifying the data accuracy, then quickly narrowing down whether the drop is due to internal changes or external factors, focusing only on the area showing unusual patterns. After isolation, the most likely cause, I would prepare a concise summary of insights and recommendations for the team. So this will be my answer. Let's just enter it. So here's my feedback. The score is 1 out of 10. And the quick feedback will be a weak answer, needs major improvement. What are the missing points? You missed these important concepts such as SQL, Excel, Power BI, Pandas, visualization. Try including them next time. And here's an AI feedback. Here are evaluations of candidate answer. So this is an AI feedback. And you can continue with the second questions, which will be walk me through your typical process when you receive a new analytical request from a business stakeholder, from initializing, understanding, presenting your findings. So this entire program will be helpful for your interview process. It's a chatbot that you have built in with the help of Gemini. Congratulations on completing this AI agent course. You have learned how to build an intelligent system that can think, remember, call APIs, analyze response, and even conduct mock interviews. With the foundation you have built here, you can now start creating a personal AI assistants, automation workflows, interview bots, customer service agents, educational tutors, productive boosters, and even multi-agent systems and ton of other projects. If you want to go deeper, try extending the project with features like voice input, UI dashboards, and connecting it to cloud services. For more such videos, do subscribe to Simplilearn and make sure to like this video. Until next time, keep learning with Simplilearn.